All right, so since we're gonna have to have a hard stop in 18 minutes, Joel, would you like to have the next 17 minutes?
Okay, so I'm just going to present on some progress that we've made with developing our alignEM-SWiFT software for aligning EM images. Working with Tom and Art and BJ and Edwin and John, James, and what I'm going to show specifically is a new way of interacting with NeuroGlancer, in which we can actually use NeuroGlancer in an embedded way, but with all of NeuroGlancer's full functionality within our application. So without being redirected to a browser. So yeah, and we're doing this using a Qt web engine. And we can now use the application starting with an unaligned stack of TIFF images and get all the way to a NeuroGlancer view and even a link that could be shared once this is running on a server infrastructure. We would be able to actually get shareable links that could be just sent an email or whatever. So this is using Qt web engine, which is what Chromium is built on. It's sort of
Joel, can you make your screen, your picture full screen? Because it's just like a little corner in mine, at least. I have a really big monitor, so.
is that the case with other people? I'm not sure that
Yeah, it's not full screen for
Same here.
Oh, you mean the
Discord,
slides
yep.
themselves? Yeah, I was gonna bring the application in, so that's why I kind of had it.
Oh, okay, yeah.
Gotcha.
We just couldn't see what you were writing about. Very good.
Yeah. Okay, so without further ado, so
All right.
here's our application.
Woo! This is the Swift, alignEM-SWiFT. Ah, I was thinking it was Swift, alignEM-SWiFT, alignEM-SWiFT glance. Okay. Swift glance.
Yeah, last night I was falling asleep to different names, maybe alignEM-SWiFT NG for NeuroGlancer, but NG is also
I like alignEM-SWiFT is cool.
Yeah,
because
yeah, that was Joel's first.
rolls off the tongue pretty easily.
All right, so
Or it could be maybe Swift Glancer.
No, it's alignEM-SWiFT.
Yeah, I was thinking about the different permutations. There's a few that could work.
Swift Glancer, that's cool.
Swift Glancer.
So I'm gonna open
Doesn't
a
matter.
project that's already aligned.
Yeah.
So starting with a project that's already aligned, and I'm not sure how familiar you guys are.
We are.
Okay, with the controls here. Okay,
Mhm.
so I'm already aligned, and yeah, I guess. Oh, and I've also exported to ZAR already, and
Wow.
there's several configurable options. So now I can just open it up in NeuroGlancer.
Ah,
It's just right. It's just right there.
It's right there.
so where's NeuroGlancer? On your machine? Your
So
own
NeuroGlancer
machine?
is on my machine. And yeah, so I'm using a fork of NeuroGlancer so that we can do our own independent development. And this is on the development branch of SwiftIR. And so we can develop in both, sort of side by side. So I keep those in like parallel directories on my laptop. I've got a fork of NeuroGlancer, and then I can clone that onto my laptop, do work, and then push the changes up to the repo. I guess that'd be a pull up to the repo. But
No, you push to the repo and pull from it back to your laptop.
either way, so
Yeah.
Push pull affair.
Yeah.
so, we'll be able to do things like as we develop tools within NeuroGlancer, like whether it's Python callbacks or something more sophisticated using TypeScript, that will all be functional in here. Because this is just like a normal. It's like this is a window. Basically, we've embedded a web browser, and so the reason I have these functions here at the print state and print URL. This isn't totally functional yet, but you can see when I go print URL, we get this long string here. and that's got the state information contained within it. So if we were on server infrastructure attack, which hopefully pretty soon here we'll be able to start testing that out, then this would be a link that you could just send to somebody, and they would be able to, because the data is all being hosted attack, and this link encodes the state of the viewer. You could go, if you find something interesting, you could shoot somebody a link and it would take them straight. It would take, just like everybody has a web browser, so it would just pull up in their web browser, not just the data set, but also the particular view of the data set that the person found it interesting. So there's a lot of exciting possibilities. So just to demonstrate that my previous callbacks still work, if I go B, we generate a blend, and right now this is popping up in a separate window, but that could be kept in the same window. So I'm going to be working on the documentation. Since we've got an embedded web browser, we can do things like this. The documentation right now is, I'd say, in a pretty lousy state. So I'm going to be working on that. I just added a link here to NeuroGlancer documentation too. So lots of work to do on the documentation. So is there any questions at this point? Oh yeah, and then also you can bring up the remote viewer. So this would be a place where, so this is on a server somewhere, presumably at Google. And again, you could pop a link in here that somebody else sends. And if you're running this application, then you'd just be able to bring this up in a remote viewer. And yeah, so then we've got different compression options for compression type, compression level, and the number of scales. So, we can just regenerate it. So let's just do like lower compression levels faster, and like we just do like 2 scales so it's faster. Then we can just export this full data set to ZAR. And another thing about the NeuroGlancer viewer is, and one of the design challenges was getting that to run in another thread, so to not lock up the GUI. So while you've got NeuroGlancer sort of going in the background, because it's a server, so it's got it to have like be running on its own thread. Otherwise, you'll freeze the interface up. So it's in a different thread. So in theory, you could have NeuroGlancer. You could be looking at something in NeuroGlancer, go back to the alignment, and continue aligning whatever your workflow is with the alignment. And so there's cool things we can do. Since we can use Python callbacks, we can start passing information back to alignment. Like maybe you go, as you're going through the image stack, you find ones that don't seem aligned properly, you can mark them, and this could all just be just like a self-contained application here. So there's even more options available at the command line from my make ZAR scripts, for example, and it's much more configurable. These are the options that are safe to adjust here, that I know I'm not gonna, that I'm comfortable putting in the GUI. And I could just ask you guys, like, pick a compression, pick a C level, pick a number of scales or whatever, and I know it's not gonna break anything. Some of these are a little bit more sensitive, but and that's basically our development model. Like, that's, so build command line tools. Command line tools can become part of the interface, and so that's one angle of development, is just writing Python scripts and functionality that at the command line that can later be incorporated into our Qt GUI here. And then at the same time, we can work on developing NeuroGlancer, by which I mean extending NeuroGlancer, and that's why I mentioned that I have a fork of NeuroGlancer started. And you can really do anything to it. I mean, it's open source. So So that's the plan. And any progress we make in extending NeurogLancer will immediately be progress that's available to us here.
So I have a question. How far are you along with Edwin to integrate NeurogLancer into Reconstruct Plus?
Well, so that's the next step. Like if I go to my last slide, that's our next step.
Have you been talking to him?
Yeah, we meet twice a week.
Great.
So
I know that Edwin is on an emergency family trip to Colombia, but he plans to continue working while he's there. Something happened with his father. It seems like my students too, like suddenly everybody's going, I got to go home. Something's happened to my family. In my class, I had to do that suddenly. You know, they were fully engaged, and it's kind of weird times these days. But anyway, he did mention, Joel, that he was planning to be continue to be engaged from there, but he may be out of pocket periodically.
yeah, so
I think you're aware of that.
that's the direction we're headed. So
This is huge progress. Thank you so much. And Terry, you weren't here at the beginning, but we had a conversation about, I don't mean to stop you, Joel. You have some more things to tell us about.
oh no, I was just going to put this slide up showing our dependencies. Feel free to talk.
This is great.
Oh, I guess I did want to talk about the project structure.
Yes, please do. Keep going back.
Sorry. So this is our project structure. So when you create a new project, you can save, and we'll go File, New Project. Yes, I'm sure. Then you can import your base images. Then you can start doing your alignment. And this is what you're going to generate every time you start a new project. So this isn't set in stone. There's things that could be changed and rearranged, but this is basically what we've got here. And you'll notice that the images are twice scaled. And so that's a challenge that we don't need to solve, but it would be nice if we could work this out where we're only generating the scale hierarchy a single time. It's made a little bit different. It's made a bit difficult by the chunked file format, the chunked and compressed file format that XAR is. So.
Oh, so that every time you want to fix an alignment or realign, you have to start back at that first step?
Yeah, so that's the idea for now. So this works, this works, but yeah, so you'd have to export to XAR again if you made changes with your alignment. If you dropped some images, or you dropped some images and then did a realignment, you would have to export to XAR again.
I see, but is there a place you can start in the middle of your effort? Like suppose you got scale 6, 4, and 2 done, and now you're going to do 1, and something happens, and do you have to start over at 6 again? It's pretty fast, those, I recall, even if you have to start over. Is that right?
Yeah, you got to so you start at the lowest scale and you work your way up. So if you change something at a higher scale, then you'll have to restart from a lower scale and redo it.
Work it up again.
Work it up again, yeah. Okay, so that's my update.
I'm really impressed, Joel. Let's say I continue to be very impressed.